friends. Today we're going to do a review of inverse operations and then use that to review one-step equations. So to start, we're going to talk about our very basic, I'm going to make that thicker, inverse operations. There are actually a lot more inverse operations, pairs of inverse operations, than what we're going to talk about today. But this is just a start. So the ones that we're going to talk about most often are addition, and then the inverse of addition is subtraction, and the inverse of subtraction is addition. So they are each other's inverses, okay? And so as a reminder, I'll do that. Inverse, you could think of it as also meaning opposite. Okay, so inverse operations are opposite on operations. They're operations that undo each other. Okay, so what that means is, for example, if I had something like I was adding 4 or positive 4, you could think of it either way. If I subtract 4, I end up with 0. Okay, in another way, if I am subtracting or have negative 16 and I add 16, I get 0. So they undo each other. Okay, and then my other set of inverse operations that we use most often, as I'm sure you could probably guess if you needed to, are multiplication and division. Multiplication and division are each other's inverse operations because they undo each other. Okay, so if I am multiplying something by 6 and then I divide by 6, I get 1. So 6 times 6 divided by 6, that gives me 1, not 0. You also could think of it like this: times 6 and then divided by 6, because remember, fractions are division. Or if we're dividing by 6, which would look something like this. Actually, we don't even need the 1. We're just going to put a squiggle. Oops, 1. Something divided by 6. If I then multiply that by 6, I get 1, and then whatever the something was. Okay, so those undo each other. So when we use addition and subtraction together, we get 0, which is the additive inverse, not the additive inverse, the additive identity. Meaning that when you add something to 0, it doesn't change. And when you use multiplication and division to undo each other, you get what's called the multiplicative identity. Okay, and the multiplicative identity means when you multiply anything by 1, you get itself. It does not change, okay? So adding and subtracting undo each other to get 0, and multiplying and dividing undo each other to get 1. So let's use that with our equations. We're going to use our inverse operations in order to solve these equations, okay? So, for this first problem, I'm going to actually do a couple of incorrect examples first, just to show you what happens. So if you're writing this down, I was just not writing this part down because I'm going to eventually erase it, okay? So we're going to draw a line through here, and this is a balance line because whatever is on this side of the equation has to stay balanced with this side of the equation. It's like a scale. And so our balance line remembers that whatever we do on one side, we have to do on the other. Okay, so let's do a couple of incorrect examples based on mistakes that I've seen, just so you can see what happens. Okay, so the first thing I'm going to do is I'm going to say, okay, x plus 3 equals negative 9. Let's think about what happens if I say, okay, I'm going to add 3 just so it matches. I'm gonna do the same thing that's already there. Okay, if I add 3 over here, I'm going to have x, and then I have 3 plus 3. What's 3 plus 3? Well, that's 6. And then negative 9 plus 3 also gives me 6. Okay, so let's talk about what my goal is here. So my goal when I solve an equation is to isolate x, which is a fancy way of saying get x by itself. Okay, and when I added 3, did I get closer to that goal? No, I didn't, because I still have, the plus 3 just turned into a plus 6, but I'm not getting 6 or x by itself. So that's not going to work. Okay, so I'm going to say, no, we're not going to do that. Okay, what if I don't know, subtracted some random number, subtracted 5. Well, then I'm going to get x, and then I have 3 minus 5. 3 minus 5 is negative 2, or minus 2, equals negative 14. Once again, my plus 3 just turned into a minus 2. I'm no closer to where I wanted to be. So I need to remember whenever I'm doing this what my goal is, which is to get x by itself. And if whatever move I make doesn't do that, doesn't get me closer to that goal, then I'm probably making a mistake. So now let's go back to the idea of using our inverse operations. So we're going to look at this plus and think, what's the inverse of plus, or adding? The inverse of adding is subtracting. So I'm going to subtract, do the inverse of whatever this number is. So subtract 3. And since I have my balance line and I have to keep balanced, I'm going to subtract 3 on this side. Okay? So 3 minus 3 gives me 0. So I'm going to end up with x plus 0 equals negative 9 minus 3, negative 12. And a plus 0, that's once again the additive identity, which means it doesn't change the value. So I don't actually care about this, so I can get rid of it. So I just have x equals negative 12. And look, remember my goal is to get x by itself, which I did. I got x all alone, and so I know I am done. Okay, so you need to remember whatever move you make needs to make it simpler so that x is closer to being by itself. So I don't want to add 3. I don't want to add or subtract some random number. I want to do the inverse of my original operation and then the same number that's right here. Okay, let's look at this next problem. So we'll start with my balance line. Then I'm going to look at my operation, which is a minus 6, and think, what's the opposite of minus 6? The opposite, or the inverse, is adding 6. And because of my balance line, whatever I do to the left, I must do to the right. Okay? So now I have minus 6 plus 6, so that gives me x minus or plus, it doesn't matter, 0 equals 8 plus 6, which is 14. Okay, and that 0 is what I want, so that means these cancel out. Those 6's are gone. So I just have x equals 14. Okay, so you don't actually have to write that plus 0 right here like I just did. if you can see and say to yourself, hey, I know that means these cancel, and you just want to write x equals 14, totally fine. I'm writing the plus 0 right there to show you what is happening, that those cancel each other out because they make a 0. Because if they make anything besides 0, they're not going to cancel. They're going to make some other number. Okay, let's look at our next one. So multiplication. So we need to remember here, well, let's start actually with our balance line. Balance line. And we need to remember that negative 4x has an invisible operation, and that's multiplication right there. It means negative 4 times x. We just don't generally write times right there. Okay? So we're going to do the inverse operation of multiplication, and that is division. And we're going to do something a little bit different. Instead of writing division like this, which might be what you're used to, we're going to write it as a fraction bar. Because we have to remember that fractions are division. Fractions are just a special way of writing division. Okay? So I'm going to draw my fraction bar to make it divided. So divided by, and I'm going to divide by the number that's there. I do the same thing over here. Okay? So, just to show you what's happening, kind of have you think about what's happening. This right here, if I have negative 4 divided by or over negative 4, that turns into a 1. Negative 4 divided by negative 4 is 1, because anything divided by itself is 1. So that's 1 times x equals 20 divided by negative 4 is negative 5. But does it make a difference when I multiply something by 1? No, it doesn't. So that's not actually necessary. So my answer, is just x equals negative 5. So when I do negative 4 divided by 4, those cancel. The inverses essentially cancel each other out. So they go away. So we canceled there. We canceled up here with our subtraction. And even right here, this plus 3 and the minus 3 cancel each other out. Okay? So then last, we'll look at our division. All right. And the inverse of division is multiplication. So you see here we have our x over 3. So we're going to multiply by 3. You also could write it down here if you wanted, but I think it's easier to see what's happening if you put it up top right here. Because the 3 is on the top and we have a 3 on the bottom. And so 3 over 3 is equal to 1, which is what we want. That's that. If we go back over here, that multiplicative identity that we had over here is 1, which is what we want. Okay, so these 3's are going to cancel each other out. And if I multiply by 3 there, I also should multiply by 3 here. And so I'll have x equals 33. Okay? So, our big ideas that we want to remember our goal, which is to get x by itself. If we don't get closer to our goal, if we get further away or stay the same, then we made a mistake. We want to remember to use inverse operations. So think about for each operation what the inverse or the opposite is. And we want to remember to use that same number so that they cancel out. So plus 3 minus 3, minus 6 plus 6, times negative 4 divided by negative 4, and divided by 3 times 3. So when we do the inverses, they cancel out, and we get x by itself.